Welcome back to the second part in setting up a Raspberry Pi machine learning cluster. In this video, I'm going to continue where I left off last time, which left us with Hadoop and Spark set up on our cluster and master node respectively. The next step is to modify our initial configuration we had in the first video, and we changed the configuration to be set up for a multi-node cluster. Now, I won't be covering this step explicitly because linked in the description is a detailed walkthrough on GitHub if you want to further reference this step. After modifying the config files, we format the cluster data and name nodes to be empty before doing anything with the cluster. This step can be repeated if the cluster ever becomes corrupted after we do this formatting. Then, navigate to your Hadoop home/etc/Hadoop directory and modify both the master and worker files there to contain the corresponding nodes. With identical configs of all nodes in the cluster, we can simplify the host file now and copy it throughout the cluster, then reboot. Now we can go ahead and start up the cluster. First, we format the Hadoop distributed file system, then we start the file system along with the Yarn resource manager. And once they're started up, we can view the active processes using the JPS command. If we SSH into one of the worker nodes and use the JPS command, we will see that the data node and node manager processes have been offloaded from the master node. With the cluster working as it should, we can now finish up the Spark configuring. To do this, we are going to generate, then modify the Spark default configuration file. Now we make a Spark logging directory to hold the auto-generated logs, and we can start the history logging server. This server can be reached and monitored then through a web browser on the master node at port 18080. Let's test the cluster. Spark provides several sample jobs with it on install, so we will deploy one that approximates Pi. While the job is in progress, we can use the history server to monitor the cluster and its many statistics as the job runs. Back on the command line, once the job finishes, among the output we can see the summary statistics on the job, and then also the final output that it calculated. The data I will be using to train my models will be taken from the Sloan Digital Sky Survey, which collects data on different astronomical objects in the universe. On their site, they provide a SQL query tool that can be used to retrieve data from their databases. After the data has been extracted from the servers, the next steps are to install Jupyter Notebook as our programming environment, along with all of its dependencies and also PySpark. Using the command line, we can open a Jupyter Notebook instance, which will open and run in a browser tab. If you are interested in a detailed walkthrough using Jupyter and the Sloan Digital Sky Survey data, check out the link in the description. And with that, we now have a fully functional Raspberry Pi Spark cluster that can be used for a variety of applications. Thanks for watching.